Well, folks, here we go. Good morning, good afternoon, good evening. We've got a busy 45 minutes and then time for Q&A. You're joining the monthly free for most of you. Some of you paid. You don't have to do that, but we appreciate the money. You know, looks like about a third of you have paid. If you want, you can just be an AFuzion client or follow us on LinkedIn. Follow AFuzion. Then these are free instead of $275. Okay, just follow. It's better. So, folks, PSAC and PHACs. You all have them. You all need them. What are they about? Well, they're vital. It's the foundation. In many ways, it's like the building plan for the building you're in. Right now, I'm in Los Angeles, and this is an old building, about 120 years old. That's old for America. Even an old building has building plans. Increasingly, EASA, Transport Canada, FAA, military, STM, all of your certification authorities worldwide are requiring improved, more detailed building plans. That's right, for your avionics. That's the PSAC, plan for software aspect of certification, and PHAC. So let's spend 45 minutes and go into detail. Okay, let's dive on in. Now, you should be seeing, whoopsie, page 2. Okay, so page 2, quick view of AFuzion. We're the world's largest dedicated aviation certification services company. We work with, about these days 80% of the world's 500 largest companies. We do training, mentoring, a lot of engineering, 40 engineers just like you. We do software systems, hardware, safety engineering. A lot of companies use our templates for PSAC, PHACs, all the plans and standards. And we keep pretty busy as aviation, like you know, is very busy these days. Our focus today, in a quick 45 minutes, 1 minute refresh on 178.254, the planning ecosystem, those 5 plans that we need, of which the PSAC, PHAC is the foundation. And then we're going to look at the outlines. What goes in the PSAC and PHAC, okay? So if you have questions, absolutely, Hakan, you posed a question just now, use the question dialog box. I'll look at those at the end in 45 minutes. Go ahead and start writing in your questions now. I'll put us on mute also at the end so everyone can ask their question if you prefer, but you can write the question and I'm just going to go straight for 40 minutes, okay? We're going to look at the key focus areas of the PSAC and the PHAC. Then, you got it. What are the top PSAC, PHAC mistakes? AFuzion writes 30 or 40 PSAC, PHACs each year, and we review probably another 50 or 75. We see a lot of mistakes. Hopefully we don't make many. We certainly have. Let's help you not make mistakes. And then what are the future technology areas that we need to include? We've built that in, okay? People think aviation is not dynamic. It's very static because they look at the airplanes and say, look, that old Airbus, Boeing, it's still flying, right? Well, it is, but the avionics, the technology, how we make software, hardware, and most certainly, truly, how we certify it are very dynamic. Now, let's take a look. The ecosystem, it's not just 178 for software or ED12C in Europe or ED80 for hardware in Europe, DO254. It's actually much more than that. We call it the ecosystem, okay? It looks like this. We're going to focus here on the software, hardware, planning certification document. But never forget, folks, increasingly the world is expanding, the universe. Your world of certification is also expanding. 4761A later this year, it's going to force you airframers, the new eVTOL companies, UAV, electric, to more closely monitor, supervise your subsystem and system providers and ensure there's no gaps in the safety assessment. The safety, the FDAL, IDAL, if you don't know what that is, Google AFuzion 476154 training. We explain that, okay, on YouTube, free videos there. And then the 4754B, many of you are using model-based systems engineering, really improved planning processes. We don't have time for that, but folks, we need safety requirements and system requirements, fed down into our PSAC and PHAC before we write them, before we approve them. This is the ecosystem, including advisory circulars and TSOs in North America or European ETSOs over in Europe. Now, planning comes first. That's why we're having this webinar. What are the 5 key plans for software hardware? They're red. They come first. After the certification plan and the other plans are approved, then we can start development. Development is not just software and the hardware. It's first the requirements. Software detail, low-level requirements combined with architecture, that's design, then code, then integration. So it's all of those. In the background, we have that integral process. That's the verification of software. V&V, hardware has validation, software does not. Now, we also have reviews, tests, analysis, CM, quality assurance, certification liaison, that bridge to certification. That's the green there. Now, the optimal route looks like this. We're going to talk today about the PSAC and the PHAC, which fit right in here. But before we have the PSAC, before you build a building, you must know, what are you building? Commercial, hotel, residence. How many floors? Elevators, air conditioning. What are the safety features? Ooh, emergency exits, fire escape, fire extinguisher, multiple water sprayers, fire, yeah, everything for safety. That comes from 4761, safety assessment. QA/PA, process assurance for systems hardware, is in place. Then we have system requirements, 4754. Then we're ready to finish our plans for software hardware. We develop those along with the standards checklists. We have traceability, okay? We trace before software hardware the safety requirements to system to hardware software. And then CM to capture, baseline all these, our first SOI meeting, stage of involvement. Then we start implementation. That's the purpose of that PSAC PHAC, to show us, ourselves, and the certification authority what we're building. You would not build a building without knowing how many floors, elevators, emergency systems. It's the same way for aviation. Aviation is much more complex than a building, okay? Then we need traceability. Traceability increasingly is the key. 178 did not previously call for bidirectional traceability. It does now. 254 has never changed. Ooh, it's old. We need a new one, 254A, but we don't. Instead, well, we're working on that now. It's going to be a few years. We have 4 new interpretations. Yeah, that's AC 2152, CAS 27, CAS 30. Those don't exist anymore. We have EASA, SWC EHC M001, and today what we all need is AMC 2152A. Really important, a new interpretation, the latest, hopefully final interpretation worldwide. That's what our PHAC needs to address. We're going to talk about that for 5 minutes in a few minutes, okay? Now, 254 does not call for bidirectional traceability, but we use the 178C definition so that we have also for hardware bidirectional traceability throughout the ecosystem, aircraft, including safety requirements from the AFHA, PSA. And then, and if you don't know what those are, I apologize, we don't have time. Look at our white papers, they're free on the AFuzion website, download those. And then system requirements, those need to be in place before we finalize the PSAC and the PHAC, okay? That PSAC PHAC is going to address how we decompose high-level requirements from those aircraft system requirements into low-level requirements, architecture, and that comprises design. Then code, tests, top-down, bottom-up, closed-loop, connected for DAL ABC to structural analysis, not testing, structural analysis, the degree to which our prior tests covered all our structures if people can be injured. Level C, die, level B, potential plane crash, level A. Similar for hardware, except the advanced analysis covers, hardware design, logic, HDL, Verilog, VHDL, but only for level A, B, but bidirectional as well. Now, let's look at our plans. Let's focus on the certification plans. That's where we show we know exactly what we're building, what system. What is our architecture? Life cycle. Where does our software hardware come from? How much of it is cost? How can we show determinism? Because we understand, all of us, that avionics is only as strong as the weakest link. You, me, all of us, we cannot be the weakest link. So we're going to look at what goes in that PSAC and PHAC, but keep in mind it's part of the ecosystem. That means we need a QA/PA process. What are our methods for doing QA? Okay. How do we track? What's our conformity review? We all have changes. At the end of the project, we are going to reference and build an accomplishment summary, hardware, software, system. We're going to mention that briefly in the PSAC, PHAC, but we're going to show that all of our changes have been synchronized. That's the conformity review, so we're safe to go test flying, because possibly the day after certification, test flight, then CM, can we build, perform regression analysis, perform root cause analysis throughout the life of that aircraft, 30, 40, 50 years or more. How do we perform V&V, verification of software hardware? Validation, are the requirements correct, complete, unambiguous, verifiable? How do we do test, reviews, analysis, test environment? And then how do we actually develop the hardware, PHAC, and the software? Are we using OO, Agile? Ooh, that's interesting. Structured, waterfall, model-based development, many of you. What's our development environment? Now, folks, you are smart. You're like Einstein, truly. You're smart enough to log into this webinar, right? Well, the documents aren't really for you. They're for us who certify you. FAA, EASA, military, whoever's doing your certificate. They're for your future engineers who aren't yet on the project, but next year, next decade, they're updating your software and hardware. How do they learn? They didn't create the product. They didn't write the documents. You did. They learn from your documents. That's why we need detail in your documents. What do they need to know to make changes safely? Okay, so let's look at those PSACs and PHACs. Now, PSAC, PHAC, it's a plan, not a recipe, not a detailed process. How we're going to certify, what's important to show safety, certifiability, determinism. We say keep it concise. Let's see. Let me ask you a question. Raise your hand if you have ever seen a PSAC or PHAC more than 100 pages. Almost half of you. Wow. Almost half of you have seen a huge PSAC, PHAC. Folks, if you have a very complex distributed flight control system, maybe. But usually 100 pages means it's not a plan, it's a recipe, okay? So we want to keep it concise by putting the details, not repeating, summarizing from the other 4 plans, QA, PA, development, CM, verification, validation, hardware. We're going to show compliance to point to the other plans. We're going to meet all the 71 objectives, DAL-A software, 62, DAL-A, you got it, no, that's DAL-C software, right? Hardware, how do we comply with not just 254, but AMC 21528? And then of real concern, folks, and we're going to address this in the mistakes, best practices, we need to pay attention to technology that potentially changes, affects, maybe subjugates our certification. What tools are we using? Are they criteria 1, 2, 3? Criteria 1, development tools that could cause an error. Criteria 2, a hybrid tool, verification plus a reduction, automation, replacement step, or verification. Criteria 3, are we reviewing the output of those tools? Are we? If not, qualify. You don't do both, too much money. You pick one, we'll talk. What COTS products do you have? Are you using and RTOS, a certifiable RTOS. Libraries from TI, from Microsoft. Ooh, that's interesting. What COTS IP do you have for FPGAs, perhaps? Where did those COTS IP libraries come from? Do you have configurability? We want this. Folks, if you have configurable software, you maximize reusability. Instead of 71 objectives, DAL-A software, you have 2. Ooh, think of that. But you have a little more work to do because you have to demonstrate you understand those configurations. What's the minimum max range? Oh, what are the requirements for each parameter data item? Who reviewed it? Who traced it? They're high-level requirements because they pertain to hardware. They're stored external to the executable. That's a hardware-software interface. How did you test it? Okay. Did you cover all the parameters? Are they safe? And then multi-core processing. How are you applying hardware-software regulations for AC 2193? You all read the news? The old CAS32A, bye-bye, adios, right? Sayonara. Well, how do we do that? What about previous developed software or hardware? How is it certified? How are we going to show certification to reuse it safely? And then safety, increasingly important. Are we applying 4761 or 61A? Ooh, what about the safety requirement attributes? Have we captured all of the FHA, the PSA, the PSAC within safety requirements? Do I have any derived requirements? We're going to talk about that. Big mistake in PSAC PHACs, not addressing derived requirements. And folks, please don't tell us you don't have any derived requirements. All your requirements have parent requirements. Let me show you why they don't in about 10 minutes. Then, can you prove determinism? Ooh, data flow, control flow, coupling analysis. Have you really shown that all foreseeable operating conditions, let's repeat, all foreseeable operating conditions have been verified? Ooh, we're going to do that. And then, what's your certification basis? Folks, we're updating the rules all the time. 5 years ago, Europe and America did not have eVTOL, electric vertical takeoff and landing. Yeah, certification rules. We do today. They're still evolving. Rules for unmanned vehicles, using multi-core, using libraries, using COTS. Ooh, it's all evolving, but you don't go back and recertify. Otherwise, we'd have really safe aircraft. They'd never fly. We'd be going back and back and back, updating for the new rules. No, you all define in your PSCP, your project-specific cert plan, your cert basis, the basic rules that apply to your approval process, how you're going to show airworthiness, which ACs, advisory circulars, apply. And we want to include a brief top-level schedule. When are your SOIs? When is the certification authority, EASA, military, CASA, Transport Canada, FAA, when are we expected to be involved with them? Okay, so this is a PHAC content summary. Now, we're gonna post this video. We're gonna give you all a link so you can screenshot this video, okay? I promise we're gonna do that. We're gonna give you a link, okay? And you can take screenshots, expand it up, put on your glasses, read the fine print, right? Well, real briefly, we want that PHAC, and this applies to PSAC obliquely, to summarize the system. What are you building? What's a quick half-page functional description? What are the components, subsystems? How could each of those fail? What's the architecture? How much redundancy, monitoring? What communication channels are we going to have? Which functionality is allocated to hardware versus software? And are we referencing system documentation? Because if we don't have system documentation, we don't know how many floors are in the building. Why are we submitting building plans if we don't know where the elevator is? Ooh. So let's talk about that, the hardware. What are the hardware functions, items, architecture? What new technologies are we using? Are we using FPGAs, COTS IP? Ooh, fault tolerance, fail safes. What is my redundancy scheme? How do I show zonal protection, particular risk protection, common mode analysis, all of the common cause aspects? Do I use partitioning? Is that with an RTOS? Is that physical? What about custom logic? This is a key focus for 254. Of course, software is always custom unless it's certifiable, RTOS, right? Well, what are those devices? What individual simple and complex devices do I have? What circuit board assemblies do I have? Am I testing those at the hardware level or at the system level? And then certification considerations. What's the basis? Am I applying AMC 21528? Am I planning on a FFPA, functional failure path analysis? What's my hardware design lifecycle? How do I transition entry exit from hardware requirements, decomposed from system requirements allocated to hardware? What are my groups of functional hardware blocks in my conceptual design, then detail design? How can I implement hardware from my detailed design? Software, 1, 2, 3 also, but 2 levels of requirements, high and low. The lowest level of requirements is iterative with architecture, so it's part of the design process, we say. And then how do I make hardware and software? Am I waterfall? Please don't do that. Agile, please don't use full agile, use safe agile. If you don't know what that is, we don't have time. YouTube, AFuzion, Agile, 178C. We have a nice 1-hour free video there you can watch. And then, what data am I going to make available? What are my risk areas? Multi-core processing, COTS, product service experience, especially for hardware. What tools am I using? Are they criteria 1, 2, 3? Development, hybrid, verification. How am I going to review their outputs consistently or qualify them? Okay. What alternative methods am I using, and what's my schedule for FAA, EASA, military, certification authority meetings, SOIs? Okay. Now, this is a table of contents from the AFuzion template. I'm looking at the attendees. I think looks like over half of you are using the AFuzion templates. Cool. They're pretty good, but remember, they're templates. They don't fit anyone perfectly. You got to modify them just a little bit for your product. So when you get the link to the recording, take a snapshot of this if you're not using the AFuzion templates. Remember what we say. Borrow them, beg for them, buy them, or steal them. Please don't steal them. That's not appropriate, okay? But here's a table of contents. You can see about how many pages we have. You talk about, in this case, the software. What does the software system look like? What are the system functionalities? Where's the software host DSP, microcontroller? Ooh, microprocessor. Where is it a system on a chip in C code? That's software. And then how do I execute software? Do I have an RTOS, a kernel? What are my certificate? Additional assumptions, okay? Additional considerations. And then my life cycle. Where do I get requirements? High level, low level, design, architecture. Where do I really create those? What is my verification process? CM, quality assurance. How do I perform all these, and what are my transition criteria? How do I transition inputs, outputs, entry, exit from system requirements to high level, to low level architecture design, to code, integration, tests? What's my organization look like? Am I outsourcing? What additional considerations do I have? Alternative means of compliance, tools, previously developed software, options, flexible, user modifiable, all these things. There's some key figures depicting all that. I'm definitely going to have less than 100 pages, okay? Now, let's take a look at what we think are key PSAC topics. First, derived requirements. We all have them. They come from design decisions, not parent requirements. They're based upon a desire to incorporate force, design constraints, fill the gap, defense, developers, system engineers, safety decisions, okay? These are examples of derived requirements commonly. Safety requirements, health monitoring, deactivation, switchover. How fast do I pull? Am I 50 hertz, 20 milliseconds? Whoops, sorry. What's my architectural choice? Triplex or dual monitor? Do I have a heartbeat? Do I cross monitor? Do I self monitor and share? How do I notify system level that I've reset, or should they reset me? Do I have a tertiary third monitor? Do I have a watchdog? What's the frequency? How do I strobe at what register with what value? Ooh, how long until the next strobe? What about dissimilarity? Definition of hardware, software, I/O, bit patterns. These are all derived requirements, okay? They don't trace directly to a system. Now, you can add a system requirement, and that's fine, but make sure it follows the 4754A system requirement standard. That one's necessary, okay? Fully maps to, correlates the aircraft system safety assessments, and then you can do it that way, add a parent requirement. Now, derived requirements, they're not derived from a parent. They're derived from an engineer's desire to force implementation, close a loop, defensive, okay, add functionality. They're tested, they're reviewed. They must be tagged, identified as derived. Maybe you're using Java. Java is great for that. Use the attribute derived requirement, okay? That ensures that you can feed back to safety, because all derived requirements must have safety approval. Think about it. Regular requirements, not derived. They trace to a parent. When you review a regular decomposed requirement, you review it. Ooh, what are the 5 inputs to a requirement review? The requirement you're reviewing, the parent requirement, traceability from the parent to the requirement standard, and the checklist. But guess what? If it's derived, it doesn't have a parent. It doesn't have traceability to a parent. It might be unsafe. 178C explicitly says, 254 does not. 178 explicitly says all derived requirements must be fed back to the system process until the safety is affirmed, okay? Well, 254 doesn't say that, because 254 is old, but we use the same process, the same ecosystem, okay? So it is required to also do that for hardware-derived requirements. That's the process. Prove that safety has reviewed it via systems, and it's safe. Now, tool qualification. Big problem in PSAC and big key area. All of these are tools. Tools, remember, are software that doesn't fly. Tools are software. They're programs, but they don't fly, so 178 does not apply to them. Instead, DO 330 applies to software tools. These are all software tools. These are criteria 1, what we used to call development tools. They could insert a defect. Yeah, compiler, linker, modeling, code generators. Now, these are criteria 3 tools: static analysis, test execution, Jenkins, structural coverage assessment, test checker, test pass fail. These cannot cause a defect. They can fail to detect a defect. Well, you have a choice always. You can review the tool output, or you can qualify the tool. Don't do both unless you have unlimited money. Remember, if you have unlimited money, who are you going to call? AFuzion. That's a joke. Don't do that. We're busy, okay? Save your money. That's why we're doing this free webinar, to reduce your cost, right? You only have to do one: review the tool's output or qualify it. Which should you do? The cheapest one. Just consider, how many times will you have to review the tool's output? How much time is involved? What would it instead cost you to qualify the tool? Choose the cheapest. Got it? Now, tools. When you qualify them, you need a qual plan. You're going to use checklists, processes. This is what you're going to summarize in your PSAC and your PHAC. Then you develop or buy the tool. You have operational requirements. You develop the tool requirements. They're software, remember? Design, code integration, operational integration. And then the actual verification itself, reviews, tests, analysis, V&V of the tool. And then background, integral processes, just like software, CM, QA, tool qual liaison. So when you don't always review the tool's output, you're going to qualify to DO 330. You're going to summarize that in the PSAC. Okay, now let's talk about PHAC topics, key ones. AMC 2152A 254 has 5 versions. Okay, there's really only one version, it's 254, but it has 4 subsequent interpretations. The most recent, 2.5 years ago, worldwide now, is AMC 2152. Balancing and circuit card assemblies no longer required 254 if they're fully covered at the system level and you're using ARP or ED79 in Europe, 4754A, ED79A. Otherwise, 254. Now, COTS hardware, there's a lot of COTS in hardware, much more than software. Well, what COTS is it? It needs a complete function definition, thorough test of that functional definition, strong CM. What version are you really using? Are you using that version consistently? You're producing these systems, the hardware, for 30 years. Does the version change? What data sheet? What errata sheet? For every box, LRU, hardware that's flying, what exactly is flying? Can you perform regression analysis, root cause analysis, if you should need to? A crash. Now, COTS IP 254, remember, is old. Yeah, almost as old as me. Not quite. Well, yeah, we learn things as we get older. Oh, don't we know? Well, 254 doesn't talk about FPGAs, modern COTS IP. We like libraries of logic, okay? We can have hard IP, soft IP, soft is best, most reusable. But you cannot simply use any, COTS IP. You need to define how you're gonna select suppliers, how you'll assess them, how you're going to have planning, detailed and derived requirements for that COTS IP, how you're gonna integrate it. Class, probably we mostly trust the COTS IP vendor, not completely. We don't trust anyone fully in aviation. So we especially don't trust people who didn't develop the COTS IP but are using it. That's us, that's you, that's me. So how do we prove we use it safely? How do we integrate, verify that COTS IP? We need an electronic components management plan, not for software, but for hardware, ECMP. How do we manage all of our hardware devices, our COTS IP? How do we mitigate single event upsets? And how will we feed back, just like software, derived requirements to the system process to show it's safe? Okay, now COTS IP, real briefly, and you'll have the slides to look more at this later. Need to move along. How did you identify the COTS IP? In what format? How do you integrate it within your design flow? Are you using MathWorks, Simulink? Are you using, ModelStem? What tools are you using? How do you integrate the COTS IP? And then how did you assess the COTS IP, the data? What are the functions, the development assurance process that you're using? And then how did you plan, write requirements, including derived requirements, integrate, use, verify that COTS IP? And then what tools did you use? Did you review the output? Probably. Or did you qualify the tool? Okay. Now, how did you select the IP core? You have to show that the IP is actually suitable for the intended function. Your PHAC summarizes this. What's the design, architectural choice? What data are you going to use? how do you physically create that implementation? And how did you demonstrate that the COTS IP fulfills that intended function? You see, these are risk areas, and that is a key area in your PHACs. When I'm reviewing, certifying, auditing, which I do for many of you, this is what I'm looking for. I know you know the basic functionality. I'm looking for the risk areas. This is a key one, okay? Now, let's talk about some key mistakes, shall we? So, PSAC. Folks, software is more than a collection of components. It's how all those components interact. We all use compilers. We have libraries, perhaps from the compiler vendor or the IDE. What's the development environment I'm using? How can I show consistency that my environment, my libraries are not the weak link? We don't have time for cybersecurity, DO326 or ED202A, but you know that hackers are increasingly interested in your libraries. They're an attack vector. How are you satisfying DO326 and ED202 over in Europe? Okay. If that doesn't ring a bell, not familiar to you, Google AFuzion cybersecurity DO326 free training webinar. It's up on YouTube. Now, what are the transition criteria? How do you progress really from high-level requirements to low-level? Where's the rules? Your requirement standard, your design standard, to architecture. Ooh, remember, low-level requirements and architecture, the combination is design. Now, how do we ensure that your low-level requirements are detailed so that when we test the requirements, we're covering 95% of all the logic? How did you assess? How do you document internal interfaces, semaphores, global data, calling sequence? How did you assess data flow, control flow? How did you perform coupling analysis for DAL ABC? What about deactivated code? How did you show it was really deactivated? What about parameter data items? Do you have requirements, review of requirements, tests, review of tests, configuration? Are you using multi-core processing? Okay. What about potential interference analysis? 3 fingers, folks. Shared cache, shared communication, ooh, shared memory. The 3 primary areas that you don't have direct control over. How do you use core affinity, asymmetric processing? That's referenced in your PSAC, summarized, detailed actually, in your software development plan. How'd you follow that? What about model-based development? Remember, we have ARP 4754B. We like models. Models are terrific to encapsulate, have a hierarchical, reusable definition of system level, common language. How do you do that? And then OOT, tools, qualification. How did you analyze traceability? Did you really perform RBT, requirements-based tests, instead of low-level unit tests? Okay. How did you really perform regression analysis, show you had no unwarranted changes? Well, the PSAC summarizes these things and references the development plan, verification plan. Now, another common PSAC mistake is thinking that DAL-C has less software development detail and quality than DAL-A. Folks, you might think so. DAL-A should be 1,000, 10,000, depends on the type of aircraft, more reliable than DAL-C. And that must be improved software design, software requirements, software coding rules, right? Surely not, absolutely not. No, look at 178. There's no difference in developing, designing, coding DAL-A versus DAL-C. What's the difference? The verification, a lot more verification work. Go ahead, look at the tables. Table 2 through 7 in the back of 178. Yeah, quite fascinating. Now, weak derived requirements, safety feedback. This is often missing, okay? We have to show that we did it. Now, 178C does not give us the recipe, doesn't tell us how to do that. It says that's your responsibility. 178.254. They don't provide the boundaries, the recipes. They can't. It's your project, our project. We have to do that. That's the purpose of our building plan, the PSAC and PHAC. Okay? Let's look at PHAC, shall we? Common mistakes. We all have hardware suppliers. We don't make our own capacitors, resistors, gates, okay, our FPGA silicon. Well, we program. How do we manage the hardware suppliers? Hardware is, ooh, software people, close your ears. Software people, don't listen, please. I'll offend you. Hardware is more complex than software. Software just has a compiler and a linker. Software is complex, I know. I'm making a point. Hardware is more diverse. We have circuit cards, power supplies, LRU, ports, communication, solder, devices, thermocouples, thermistors, resistors, FPGAs, PLD. Ooh. Hardware is much more diverse. If it has weight and mass, it's hardware. So you have suppliers. What are the transition criteria really in managing, developing your hardware, inclusive of all those suppliers? How do you really prove simple devices are simple? Are you using CAS30? Not anymore. AMC 2152A? Ooh, is it really simple? Is it asynchronous? Does it have staged? Ooh, stages, internal logic. If it's simple, we don't care about the process. All devices that are simple are automatically DAL A, but increasingly it's hard to prove simple because it's not. If it's programmed, probably it's complex, unless you can truly, with evidence, prove all foreseeable circumstances we covered. Now, weak details on COTS IP, how you select those prior 2 pages. Look at those, review those. What are your custom devices? CBAs. How do you really deploy AMC 2152A? It's the new Bible. Now, what about level A, level B? Okay, remember, people can die level A and level B. How did you perform the FFPA, functional failure path analysis, element analysis? If you don't have mere VHDL Verilog, you've got hardware elements. How did you analyze those? What tools did you use? How do you operate the tools? Ooh, you don't qualify them, perhaps? Okay, how do you install? How do you operate? Remember, the directions aren't for you. They're for the future people who will use your hardware. Yeah, make changes. Are they well documented? Now, what happens if you don't perform FFPA element analysis, right? And do you really have an electronic component management plan? Can you prove all that reference data is under configuration control? That's the PHAC. Okay, folks, you made it. Woohoo! We are 1 minute behind schedule. I apologize. That was 46 minutes instead of 45. I say that is a big success. Let's move on to questions and answers, shall we? I see they've got quite a few questions. Okay. Jose Miguel, great to hear from you. Thank you very much. Yeah, you can certainly ask any questions you want. Now, Mohammed asked, what's the outcome from the green box develop traceability before SOI 1? Great question, folks. Yeah, remember the green snake? Yeah, we call it green because that's the color of American money. Really, that's why we made it green. This is expensive. This stuff adds cost. 178.254 is not free, but Mohammed wisely points out that there was that traceability. We need to trace from the customer, aircraft integrator, aircraft requirements, aircraft FHA, preliminary aircraft safety assessment, PSA, PSA. Ooh, have to trace those requirements into the system, which is then 4754, and that includes the PSSA, the Preliminary System Safety Assessment, additional safety requirements, tracing those into software and hardware. So the PSAC, of course, is software. PHAC is hardware. Some requirements are allocated to both software and hardware. So three choices. Which of those aircraft system safety requirements are allocated to software? Which are allocated to hardware? Which are allocated to both? Yeah, that's the traceability, okay? If I don't have at least partial traceability before my PSAC PHAC is approved, how do I really evaluate that that architecture defined in the PSAC PHAC is complete? Remember, the architecture is going to show redundancy, safety. It's going to show the presence of fault logging, fault reports, outputs to the pilot, switchover, right? If I don't know about those requirements, how can I really say my PSAC PHAC architecture is complete? I can't. Good one. Okay. Gene Buckamore. Is the PSAC PHAC more relates at the SFHA, PSSA, SSA system level? Great question. It's more at the PSSA level and the system level. It would not, the PSAC would not be SSA related. The SSA, well, remember folks, the order FHA top-down, functional hazard assessment, aircraft system, and then preliminary system safety assessment. Preliminary because it could be updated. Also top-down, but inclusive of FHA system requirements. And then bottom-up SSA. That includes the FMEA. I need to know the actual devices, not for software, but for hardware. Yeah, Sanjeev Akamar, I do need to for the hardware. Look at the SSA also, but not complete. Remember, the SSA is not completed until my hardware design, all the devices are known. I can have the PHAC before that time, okay? And another question. If you define system level requirements to derived requirements, this aspect takes away the freedom for the designer to implement the best possible solution that is available at their disposal. Is this recommended? And I agree that all derived requirements should meet the SSA. Yeah, it's a good question. You know, I would say it's subjective. There's nothing in 4754, 178, 254 that dictates one way or the other. Okay, so I would say it's a function of the quality of your system requirements, the quality of your system engineers. Okay, if you have very good flow down aircraft, FHA, PSA requirements, if you have great system engineers, let them do their job and let them take the lead at that. If they don't or aren't, your customer's vague, then I vote for the opposite. Let the designers have more freedom, okay? So it's gonna be your requirement standard, design standard, development plan that's gonna tell us that, okay? Mike asks, you mentioned that 254 is no longer required for Dow D. What about 178C? Oh, fully required, because the reason, Mike, is because if we have good 4754 mandate and are following it, and we have good system requirements inclusive of the hardware, okay, and we're going to test those at the system level testing, then level D black box hardware doesn't add anything, but software still has high level software requirements, low level requirements. They're not verified, but documented, okay? So robustness testing of those at the requirement level, those would not necessarily be covered at the system level testing. So software level D still requires 178C. Okay, Daniel, do you suggest using both AMC 2152A and AC20? Ooh, it's a great question. If today I would use all of them, I tell clients to read all of them. Now with software, the good news is you don't have to read the prior versions, 178, 78A, 70B. Hardware you do. To really understand hardware, I think you need to understand how in 2005, AC 2152 on the American side, FAA, reduce the scope, focused 254 on the CEH, complex electronics hardware. I think you need to read CAS 27, which was Europe approved also, okay? CAS 30 for how to determine simple, it really helps. It's not applicable, but it really helps. And then all of us should read EASA Certification Memo SWCEH 001, okay? It never applied to the Americas, but most of you Americans are also making product that could be certified in Europe or flies in European aircraft. We have a bilateral agreement, but that's kind of changed a little bit with 737 MAX stuff, right? So I would read all and recognize that today we really only need to apply with 254 plus AMC 21152A, AC 2152A for the Americas, or AMC 2152A. I would personally probably veer towards officially following 152A in the Americas, AMC 2152A, if I'm going to be exporting or used in Europe. A little tighter rigor. Okay. Fabricio asks, can you repeat why 254 is not applicable to the hardware level D? Yeah, because if we're following 4754, we should have requirement standard development process at the hardware level, inclusive of all the actual hardware. So our system tests would be testing that hardware, okay? And no one can be seriously injured for DAL-D failure. Now, the Europeans don't like that. So usually over in Europe, DAL-D does get a 254 mandate. Life is not fair, right? And Fabricio, you're over in Europe, so sorry, buddy. DAL-D is probably going to require ED80 DO254. Sylvain, oh, thanks, very good. Appreciate it, Sylvain. Good to see you too. Fabricio asks also, I'm developing a unit based on COTS boards, and it's not clear how I can address the strategy for boards without certification credits. Ooh, Fabricio, it depends on the DAL. If you're DAL AB, you're right. You're going to need vendor support. Curtis Wright, the old Die4, Intel, there's a lot of vendor support out there. If you're DAL C and D, you can do a lot on your own. Whoops, that's the alarm telling me we're done. Let me turn off the alarm. I'll give you a couple more minutes, okay? I see we got a couple more questions, so we'll go over time a little bit. And what do we got next? Do we do on-site training? Yes, we sure do. Thanks very much. Bharat asks, 178C requires the PSAC to describe the system's functions and their allocation to hardware software. How much detail is expected in the PSAC with regard to system functional allocation? Ooh, Bharat, great question, man. I've seen PSACs with 20, 30 pages of that detail. I hate it. I think it should be referenced. I'd rather see a reference to a detailed system specification, okay, where all that detail's there, but summarized. I would have 2 or 3 pages in the PSAC that summarize the system architecture. Then I would reference that information in all the other plans and the hardware plans. So I'd have a 1-page real brief summary in my PHAC and then reference the PSAC. You can do the opposite, but most authorities tend to look at the PSAC first, kind of model it, okay? Todd, what's the best approach if the PSAC must be updated later in the project? Ooh, great question, Todd. Hopefully it's minor changes, okay? In which case we don't update the PSAC. We summarize those changes because they're minor. That means regression testing doesn't subjugate the certification. I summarize instead in the software accomplishments summary. But if I make a major change, moving functionality, I add multi-core, I move something to an FPGA, I have partitioning, I change the DAL, I'll move it up, usually goes up. Oh, sorry, that's going to be a new PSAC, so I'm going to try to minimize those changes. Okay, Sylvain, concerning derived requirements, how can safety system engineers understand the safety impact of low-level software FPGA requirements? Yeah, especially the low-level ones. Now, the high-level requirements are the interface of hardware software more likely. So system engineers should be able to grasp those with a meeting of software. They won't be on the low level. You're right. So have a meeting between systems and the software designer. The software designer is going to do most of the talking, right? We've got 2 ears, 1 mouth. That's the reason for that ratio. When the system engineers are listening to the low-level software designer describe their rationale for those low-level requirements. Now, remember, the attribute of the requirement, including low-level derived, should try to justify why that low-level requirement is necessary and why it's safe. So if you have a requirement design standard that calls for that, then that takes care of it right there. So the software engineer designer would specify the rationale so the system engineer can more likely read that. Okay. Mitch asks, you mentioned derived requirements in the PSAC. Shouldn't they be in the SRS? Oh, Mitch, you're absolutely right. The actual requirement, my apologies, folks, if I said the requirement themselves should be in the PSAC. They should not. The PSAC should address how you feed back the derived requirements to the system process inclusive of safety, how your requirements management process tool preferably tracks those derived requirements. The actual derived requirements, which is absolutely right, those are in the software requirement specification. Folks, I apologize, you got a few more questions. If I didn't get to your question, and it looks like there's, we had a few hundred people today, there's a few questions still left. Pop me an email, okay? And I'll do my best to answer it by email. Great having you, folks. Good seeing you. Hope you enjoyed the free AFuzion webinar. Oh, and hope we see you in Germany, okay? I'll be there in 5 weeks. Aviation Tech Week, March 29th, 30th in Munich. Awesome. Hope to see you there. Take care, everybody. Safe skies always. Bye-bye.